Hi, welcome to another edition of Design Spark Ask the Expert. Today we're talking to Microchip. We're going to be talking about silicon carbide devices. They're becoming more established within the industry, better thermal conductivity, lower switching losses, and less heat generation. So, can SiC be considered to be the dominant material within power electronics? Today we've got Mark Romerswinkle to answer those questions. Hi, Mark. Welcome to Design Spark.
Hi, Greg. Hey, good to be here. Thank you for inviting me for this interview. So, my name is Mark Romerswinkle. I'm based here in Germany, and I'm taking care about the business development of Silicon Carbide in Europe. And happy to be here with you.
Fantastic. So, Mark, there's an ever increasing demand for silicon carbide devices. A lot of that's down to the automotive industry, where we're seeing obviously more integration with silicon carbide. But where else are we seeing that growing demand happening?
Yeah, we see it nearly everywhere. So you know the term electrification of everything. So we see it really everywhere. So automotive maybe is the biggest industry, is the traction inverter of automotive and the OBCs and all that kind of stuff. But nevertheless, we see it in every application where you have more than 600 volts, more than 3 kilowatt roughly, and where people are switching from silicon devices, so silicon IGBT, to silicon carbide MOSFETs. And it's coming up every day. And the markets, if you ask me what kind of application in markets, I would say EV, as just said, but also EV charging, because we need to support to charge the cars. We need the infrastructure for charging the cars. So EV charging is a big topic. Efficiency is key there too. And then railway applications, aviation, different kind of industrial applications, like welding, like industrial power supplies, UPS, something like that. And renewable energy systems, windmills and solar industry, it's nearly everywhere.
Yeah.
It would be easier if you ask me where we do not see it and where do we see it, because it's really everywhere. Yeah, it's really increasing. The demand will increase dramatically.
Yeah. So as you were mentioning now, the demand will increase, but obviously we're talking about diverse markets as well. So you've got automotive, and you were talking about one or two of the other markets in there, renewable, etc. So how is it that Microchip actually approaches those different types of markets?
Yeah, Microchip has a philosophy since the beginning, more than 30 years ago, that we always try to balance our revenue, that we are not dependent on any customer or even on any market. And so we try to serve all the markets, or most of the markets, also for silicon carbide. We are not just selling our devices into the automotive industry, and we are also looking after the industrial and all the markets I just mentioned. So for us, it's very important that we are not dependent on any market, and that we behave like a partner for all the customers, also for the smaller and medium-sized customers, because we grow with them, that we have history with them, and we don't want to bring them into risk because we are just selling into the automotive industry. Automotive is important for us. We are talking to the tier ones. We are talking to the OEMs. They have interest in our solutions, but we don't want to forget all the, let me say, non-automotive and smaller customers.
Yeah.
They are also important to us. And therefore, we offer the same good lead times for the automotive industry as we do for the non-automotive industry.
Yeah, that actually brings me on to the next question, because obviously with demand as well, and going across these diverse markets, as you mentioned, at the moment we're seeing a general trend for longer lead time. So how is it that Microchip are reacting to that to satisfy customer needs?
Yeah, so absolutely right. So I think since the beginning of last year, so beginning of 2021, the lead times increased, the demand increased, and all that stuff. I think everyone knows that story. Also at Microchip, we have also longer lead times than we had before. Absolutely. In terms of silicon carbides, we have some good strategies in place. So we have strategic agreements with our suppliers, also with customers. We have programs like PSP and so on to reduce the risk, reduce the lead times, and we are still in a good shape. So compared to the industry or the market, where we see 50 to 70 weeks of lead times in silicon carbide, Microchip is in the range of the 20 weeks. So depends on the devices, depends on the volumes. And it's a case today. I don't know when the people watch the video, but in the 20 weeks range, roughly.
Yeah.
And it's not by chance. It is by purpose, because for us, it is an important topic. We invest a lot into silicon carbide, but Microchip is not a company who is disclosing that to the world. So we are don't do that public. So we are careful telling the details, but we have invest a lot. Some points I can mention. As I said, we have strategic partnerships with our suppliers, and we are using market independent suppliers. So we don't get our source material from the competition, because if the competition cannot deliver, we could not deliver.
Right.
And that is something we want to avoid. Therefore, we have many different suppliers, raw material suppliers, substrate, EP, and whatever is needed, and multiple of them, and independent of the market. So, and that gives us a stability here.
Yeah.
And in the manufacturing of the devices, we have two locations where the silicon carbide devices at the end are manufactured. So where the dies are manufactured. And there are two different places, because if anything happens to one location, then we still have the other one. This is a typical idea of Microchip. I think also for other suppliers, I'm not sure, but especially for Microchip, that we, in most cases, have a internal second source, to say so. And that gives us also stability in lead times here.
And I think by what you mentioned with your average lead times as well, that's well lower than the market, more than 50% lower than the lead times that you're seeing within the rest of the market. So what you're doing is actually working there. So just tell me a little bit about if we go on to the product offering now from Microchip, what is it in terms of SiC that you guys are offering our customers, for example?
Yeah, we have a lot to offer, really. But before I give you an overview of the products itself, let me just mention, for us, it's key that we support our customers with adapting to silicon carbide with ease, speed, and confidence. And how do we do that? We try to lowering the overall system cost with our solutions because of the high ruggedness, the high performance of the devices. We try to improve the development time, so make the development faster time to market. And we do that by supporting our customers well with our TSS approach. So that means total system solution.
Yeah.
We can help the customers in the whole application. And we have a so-called augmented driving technology, which is unique in the industry, which makes it easier to adapt to silicon carbide or coming from one to the other supplier. And as I just said, we try to reduce the overall risk, not just the technical risk in the application, but also the supply certainty, which I just mentioned, that we have strategics in place to address it. When we talk about the products, so just a brief product overview, so it would take hours to talk about all the details, but roughly said, so we have diodes and MOSFETs from 700 volt to 3.3 kilovolt. So meaning 700 volt, 1200 volt, 1700 volt, and 3.3 kilovolt devices. Mm-hmm. We offer them as a die. So customers could buy it as bare dies. We offer that as classical discrete devices in SMD packages, in TO packages. We also have the SOT227 package. So many different options. We are going to release new packages always, and we have the power modules. I have some examples with me. So we do have the classical standard modules, so modules off the shelf, and what you also see from others. Most of the customers know the 62 millimeter devices. We have them also, but we have also special versions of that. If you see, the high is a little bit lower than the classical 62 millimeter, which has a high of 32 millimeters, and those things. We have smaller modules, different kinds of, I think we have 100 different modules. I don't know the numbers. We have modules with integrated gate drivers, with integrated intelligence, FPGAs also, many different options. One highlight is our so-called low inductance module, the SP6Li. It has a straight inductance of down to 2.9 nanohenry, which is very low, very, very unique in the industry. But what is also very important to note is that Microchip can offer, also for smaller customers or smaller volumes, to customize those modules. So
Okay.
if the customer
Yeah.
say, I don't want to have this topology, I don't want to have the diodes in, or I want to have a different kind of setup in it, or whatever it might be, we can do that. We can customize the standard modules, or we can also design complete custom modules.
Right. Okay.
So even for, let me say, lower volumes, yeah, I can't give you a threshold here, but if you as a customer would have the request, just reach out to me, reach out to your nearest Microchip contact, and and start a discussion from there. And I'm sure we find a solution there. So quite flexible here.
Great.
And what it makes absolutely unique is, as I already mentioned, is the driving technology, which currently fits perfectly to the power modules.
Yeah.
So there's a lot to tell you. And what makes us unique, as I already said, is the performance and the ruggedness or reliability or quality of the devices. That is really something I would like to explain a little bit more in deep if I'm allowed.
Absolutely. I'll come on to your driving technology in a moment, if I may. It was just something you said there about the working with customers to get to their needs. So one of the things, obviously, around silicon carbide devices, as we mentioned right at the top, becoming more the dominant player within the power electronics. So if customers are looking to requalify their power designs with SiC devices, what is it they need to consider? Are there any issues or problems they could face that you could potentially just maybe give a quick commentary on?
Yeah, I think there could be many problems or things to consider when you switch from one supplier to the other supplier. So first of all, a diode is a diode and a transistor is a transistor in principle, but they are all different because different manufacturers have different technologies and require different kind of driving, for example. It was the case switching from IGBT to or silicon MOSFET to silicon carbide MOSFET, but it's also the case from one supplier to the other supplier. They have different thresholds. They expect different kind of driving voltages, for example, yeah, and so on and so on, and and that makes it really a little bit more complex. And normally, if you design one system and you do the same design with another supplier, you have to change the resistors and some other stuff. But with the augmented driving technology, so the intelligent digital driving technology we offer, we can make it much easier and faster because you just adjust it with a keystroke. So it's software based. Yeah, it's a software based system, and you have your graphical interface, and you can nearly download or easily download your behavior, how to drive the transistors or the application, and that makes it really easy to adapt and much faster. You don't have to resolder anything.
Right. Okay. Great. So you did mention there about your driving. So I just want to ask you a little bit more. Can you tell me, because it is a patented augmented switching system that you have, can you just tell me what that is?
Yeah. So, thanks for asking. So I'm happy that I'm allowed to explain that because it's really unique. So normally you turn on your transistor in one step and you turn it off in one step with different kind of gate resistors. And with the gate resistors, you change the slope, how fast you drive the transistors and so on. But if you turn them on and off in one step, it could happen, especially at silicon carbide, because you can switch them very fast. Yeah. You have a high speed slope, yeah, and because of that, and because of the parasitics in your systems, especially inductances and so, you could get an overvoltage, and then you get a ringing,
right?
And that ringing causes EMI, that causes extra losses, and the high peak can damage the system.
Yeah.
In worst case, yeah. And so, how to get rid of that? And there was a company, Agile Switch, which we acquired in 2019. They had a great idea. Why not turning on in steps and turning off in steps? And with that, you can influence the speed, how it is turned on and how it is turned off. And with that, you can bring down the ringing and you can find the balance, because if you make it slower, it has higher switching losses, maybe, depends. But on the other hand, you reduce the ringing losses. And then you can find really the perfect balance to have good losses, so less losses, and less ringing.
Yeah.
And that makes it really special. And the side effect, as I just mentioned, you can change the driving voltages and all the other stuff, and therefore you can adapt from one supplier to the other, which I already explained.
Yeah.
It's really, really interesting to see. So if the customers has interest to learn more, again, reach out to us. We are happy to explain how it
Yeah.
works.
That sounds a really great solution when you were talking about it there, and giving obviously a lot more control over the switching as well. You can predetermine, if you like, what the effect of the switching will be by doing it in those stages. So one of the things that I think customers are always looking for, and we mentioned obviously with silicon carbide being used more. What about the reliability of the devices themselves? So you've got great flexibility in what you said about how you can work with customers to create product to their needs. But in terms of reliability, what is it that Microchip considers that it can offer its customers with that respect?
Yeah. Yeah. First of all, I just want to mention, so I'm attending many different trainings and roundtables and whatever, and have discussions with customers and also with other suppliers. And we all see that reliability is really key, and it's getting more key. So with the time, the importance increased a lot. What we think, so we are proud to say that we have one of the leading reliability in the market in silicon carbide. So the highest reliability, the highest ruggedness. And the points where we say this is important, first of all, it's the oxide, the gate oxide stability and the quality of that. And here we could show to our customers, for example, the gate threshold. There is a test called HTGB test. In the first instance, it's a static test, and you measure over time the gate threshold. So you apply a constant voltage to the gate, and positive and negative, and test it over the 1,000 hours, 175 degrees Celsius, blah, blah, blah. You do the test, and then you look, hey, how did the threshold change? In our case, it just changed 20 to 60 millivolts. So it's nearly nothing. It's noise. Yeah? But that is the static test. We spoke to partners and customers who did that dynamically, because in a classical environment, you have dynamic behavior, not the static one. And even there, we behaved perfectly. So that worked out fine. So, and I hope the customers are testing dynamic gate stress, and then they will see how good the quality is. Then another point at gate oxide is how long does it last? What is the lifetime of the gate oxide? And we can show with measurements and accelerations and so on that our gate oxide lasts more than 100 years. So no one of us will see the device failing because of gate oxide, I guess. Yeah. Then body diode stability. So each MOSFET has an intrinsic body diode because of the construction, because of the physics, and you can use it or you don't use it in an application. It depends on the quality and stability of those body diodes. And the Ohio State University did some measurements. They tested different suppliers and also ours, and applied constant current to the body diode. So the body diode was conducting whatever 10, 20, whatever amps over time, over 20 hours, 100 hours, 160 hours. I don't know the numbers exactly, but what they found out is that after a while, even after 20 hours already, the RDS-on decreases, or the MOSFET itself decreases and degraded. So some were not usable anymore, and some others got worse. But for Microchip, it showed that we did not decrease at all or degrade at all.
Okay.
So no quality issue, nothing. So they behave like a virgin device.
Yeah.
So no effect. So perfect, body diode. So why is it important, body diode? So you can use it in your applications. You don't need to apply or add an external diode. And so you can save cost, you can save space, you can make it easier. And I just want to mention, so if you add a Schottky barrier diode, a silicon carbide Schottky barrier diode, this may have less losses because the forward voltage is lower and the reverse recovery is not there. Silicon carbide, the intrinsic MOSFET, has a little bit of reverse recovery and has a little bit higher VF, so the losses are a little bit higher. But if the application is fine with that, if that works, then you can use it and save a lot of cost and space. The next point is avalanche capability. So that is my favorite, honestly. We say we have one of the highest avalanche capability in the market, in the industry. And test, which we have done several tests, but one test I like a lot is a so-called TDDB test. So we take devices out of the manufacturing and tested the TDDB, and then we take other devices out of the manufacturing, and we did a so-called RUIS, so repeated unclaimed conducted switching, so 100,000 times avalanche, 100,000 times, not just one. And then we tested the TDDB, and there were no change, no degradation, nothing. So avalanche, no problem. How does it help our customers? So normally, if you have devices which are a little bit more sensitive in avalanche, you have to add extra electronics.
Yeah.
Most cases, snubber electronics. You need capacitors, inductors, resistors, whatever next to this to take the energy of the avalanche of the high peaks. And in our case, maybe it's not needed. You can reduce it or even get rid of that. We have customers who said, "Hey, Mark, I completely get rid of my snub electronics. It makes the system smaller, more reliable, and I save a lot of money because, especially in the automotive industry, you need very expensive capacitors in that." So that helps the customers. Then short circuit wisdom time. It's a topic because IGBT normally behave better than silicon carbide. Silicon carbide has much smaller or shorter short circuit wisdom times. Our devices typically have 3 microseconds range, and we have ways with decreasing the gate voltage and the DC voltage and so on and so on, that we can extend it up to 10 microseconds. And that is a range where the IGBTs are. So that is also fine. Then cosmic ray. Cosmic ray, I think in general, silicon carbide, they are smaller, more robust, much better than IGBTs. And I think that's the case for all the silicon carbide suppliers. And the last point in regards of performance. So sorry for the long story, but so much to tell. And in regards of the performance, what we could tell is the RDS on over temperature. So normally you have an RDS on, so 20 milliohm or 50 milliohm or whatever it is, but that is just mentioned at room temperature. But if the temperature increases, the RDS on increases. For classical MOSFETs, I think it increased 100% or so for most of the suppliers. And for silicon carbide suppliers, normally 70% or so. Yeah, I don't want to give any numbers about the others, but in our case, it's more flat. So we don't increase so much, perhaps 40, 50%, depending which temperature we are speaking, 150, 175 degrees Celsius or so. So very flat curve. Makes the system more reliable. You can still parallel the devices because that's also important because of the positive temperature coefficient. You can parallel devices, what we do in our power modules, for example. So in those kind of modules, we have up to 12 transistors in parallel. And also the behaving of paralleling them, because it's also not always easy and it doesn't work fine always, but in our case it does. So the feedback I got from the market, that the switching behavior and the ringing when paralleling devices is much, much better than in the industry, in the normal for the others. So under the line, high reliability, high ruggedness, and high performance.
Fantastic. That's absolutely great to hear, Mark. So not only, as you mentioned, the reliability plus all of that extra value that you're adding in terms of less cost and smaller spacing, but also what you said earlier about your shorter lead times, your augmented switching, your patented augmented switching, plus all of those products that you can offer as well. So that really does sound like, Microchip, as far as silicon carbide is concerned, are really, pressing forward with that. So my last question to you would be, what else is there? Is there any more that we can see to come, and what's keeping you excited about silicon carbide?
About silicon carbide or about our offerings? So
everything.
Yeah. Okay, then give me some hours to explain that. Okay, let's make it short. So I think I think the silicon carbide discussion at all is very interesting. So many new applications you see in the market and so on. But what I would like to add about the microchip offering of silicon carbide is that it's not just the technology and how good we are in the devices and offerings and all that time. It's also the company, in my opinion. So Microchip is in this industry more than 30 years, and we have a lot of power experience. So even if the brand Microchip is not directly linked to Silicon Carbide, because we acquired Microsemi in 2018, it comes from Microsemi, but the complete company, Microsemi, APT, and so on, has 30, 40 years of experience in power electronics, 20 years with Silicon Carbide already. And Microchip brings in the other stuff. So the digital control loop, for example, we have nearly 20 years experience with that, and all the rest, what you need in those kind of applications. So we have a lot of experience, which we offer to our customers. So we call it TSS, Total System Solution Approach, which means the customer can reach out to us for the power stage, for the silicon carbide power stage, for the driver, the control loop, how to supply it, how to do the communication, the complete application. He has a one-stop shop for all his questions, if you like. Yeah, I think that is unique. Then we are a company with 125 consecutive quarters of profitability, for example. So very financial stable company. We have the philosophy of not end-of-life products. Yeah, that's also valid for silicon carbide. We cannot guarantee and promise something, but it's our philosophy. And we have microcontrollers which were designed in 1998, not 1998, 1989. Yeah, so more than 30 years old. You can still buy them. Yeah, we have newer ones, fresher ones, and better ones, but we still have that. So it's our philosophy not to end-of-life products. And that's maybe important for industries like the railway industry, for example, or the classical industry. And that is what I really like at Microchip, that we are not just selling silicon carbide device, that we offer a complete package to our customers. So we are a one-stop shop. And last but not least, as I said, we help our customers adapting to silicon carbide with ease, speed, and confidence. That is my slogan. I like that a lot. And
yeah.
If the customers have questions, so perhaps let me not forget to mention that if you have questions, reach out to us or our webpage, microchip.com/SiC, and you find a lot of documentation there. Okay,
Fantastic.
That's all I have to say, Greg.
Fantastic.
Nothing more.
Mark, I'd just like to finish and say, with ease, speed, and confidence, it's been a great session talking to you today, and I hope we can have you on Design Spark again real soon.
Absolutely. Thank you very much. It was a pleasure for me too, and happy to talk to you. Thank you.